Assalamualaikum and good day to all viewers. Today, Faisal will be presenting our solutions on two questions that is under the topic differentiation. To start off, we need to understand what is differentiation. Differentiation can be defined as a derivation of a function with respect to an independent variable. Differentiations are applied to measure the function per unit changes in the independent variable. To illustrate, let y equals to fx is a function of x. Then the rate of change of y per unit changes in x is given by dy over dx. In differentiation, there are a total of 8 techniques that is used to measure the function per unit changes in the independent variable. The first one would be derivations of constant functions. The formula given is y equals to c, where c is value, therefore dy over dx is equals to 0. Second, the deviation of linear functions. The formula given is y equals to a to the power of 1 plus with b, therefore when differentiated, the products will be the value of a. Third, the deviation of power functions. The formula given is y equals to a to the power of x. When differentiated, the product is the value of a multiplied with x to the power of x minus with 1. 4. The product rule. In the case of y equals to a multiplied with b, where a is equals to u, b is equals to v, the formula is y equals to u multiplied with v prime plus with v multiplies with u prime. Fifth, the quotient rule. In the case of y equals to a divided with b, the formula is b multiplied with u prime minus with u multiplied with b prime divided by b squared. 6. The chain rule. The formula is d over dx to the function of fx to the power of n is equals to n multiplied with function x to the power of n minus 1, then multiply with prime function of fx. 7. Deviations of sums and differences. In the case of y equals to fx plus or minus gx, the formula is prime function fx plus or minus prime function of gx. Lastly, which is the 8th, implicit differentiation. Implicit differentiation usually has a mixed function question, thus it requires a mixed solution to solve the equation. To give an example where this question requires a mixed techniques of product rule, chain rules, and logarithmic functions.
Now, let's move to question 2a. To find the derivative of this function, we apply the product rule and combine with chain rule. To break this down, we split the function into two parts, u and v. Our first part, u, is 3x squared and its derivative is simply 6x using the power rule. Our second part, v, is tangent 2x plus 1. Because there is function inside the function, here we apply the chain rule. The derivative of the outside tangent function gives us a secant square 2x plus 1 and multiplying that by the derivative of the inside, which is 2. Leave us with 2 secant square 2x plus 1. Since the function is a product of two terms, we apply the product rule. Differentiating the parts gives us 2x squared times 2 secant square 2x plus 1 plus tangent 2x 1 times 6x. Multiplying those out, our final derivative is 6x squared secant square 2x plus 1 plus 6x tangent 2x plus 1.
Okay, for question 2b, I will present how to solve this question. Find dy dx for the following function y equal to 4x plus 2 divided by cos x. As if you can see here, both numerator and denominator have a variable x. Are we in the same boat? Yes, exactly. We will use quotient rule on this question, which u is 4x plus 2 and u prime is 4, while v is cos x and v prime is negative sin x. I hope you know how to find the negative sin x. You need to differentiate the cos x first, and then you differentiate the x on the cos x. I hope you understand. Okay. After we define all the information, just apply it on quotient rule formula, which is vu prime minus uv prime divided by v squared. Okay, from the information we did get, we can just put it like cos x times 4 minus in bracket 4x plus 2 times negative sin x divided by cos x squared. So for cos x times 4 will be 4 cos x. Negative in bracket negative 4x sin x minus 2 sin x divided by cos 2x. And it will be, and the answer will be 4 cos x plus 4x sin x plus 2 sin x divided by cos 2x. You can leave it like this or you can expand it, but to avoid mistake, just leave it on this form. I hope you understand. Okay, next question.
Question 3. Given y ln 3x minus e the power of 2x plus 1 equal to 3x the power of 2 plus tan 4y. Find dy over dx using implicit differentiation. First, we need to differentiate both sides. First, differentiate y ln 3x. We need to differentiate both sides. First, differentiate y ln 3x. We can use the product rule because there are two functions multiplied together. U is equal to y and v equal to ln 3x. Formula of product rules is u v prime plus v u prime. First, differentiate u is 1 times y prime is equal to y prime. Differentiate v is 1 over 3x times 3 is 3 over 3x is equal to 1 over x. After that, substitute into product rule is y times 1 over x plus ln 3x times y prime is equal to 1 y over x plus y prime ln 3x. Step 2 is differentiate e the power of 2x plus 1. We can use the chain rule. First, write down e the power of 2x plus 1 times differentiate the power of 2x plus 1 is 2. The answer is 2e the power of 2x plus 1. Step 3, differentiate 3x the power of 2. 2 times 3x power of 2 minus 1 is The answer is 6x. Step 4. Differentiate times 4y. First, derivative times 4y is sec power of 2 4y. Then, times the differentiate of 4y is 4 and times differentiate of y is y prime. Then substitute all equation is y over x plus y prime ln 3x minus 2e the power of 2x plus 1 equal to 6x plus 4y prime sec the power of 2 4y. Then move all y prime terms to left side. Factor out y prime is y prime times ln 3x minus 4 sec the power of 2 4y equal to 6x minus y over x plus 2e the power of 2x plus 1. Lastly, divide both sides and the final answer is y prime equal to 6x minus y over x plus 2e the power of 2x plus 1 over ln 3x minus 4 sec the power of 2 4y.
To close the differentiation segment, I will explain on how to solve the last question. The question states, use linear approximation to estimate the value fourth root of 80.99 minus with 2 over 80.99 to 2 decimal points. As we've learned, the formula for linear approximation is function f(x0) plus with dx is equal to function of f(x0) plus with function prime of f(x0) multiplied with dx. Let us solve this question step by step. Firstly, we need to identify the function f(x) from the equation, which is f(x) equals to fourth root of x minus with 2 over third x, which when we convert it into a simpler form, it is equal to x to the power of 1 over 4 minus with 2x to the power of negative 1 over 2. Second, we have to find the equation for prime function f(x), where we apply the technique of divisions of power functions. The product will be 1 over 4x to the power of negative 3 over 4 plus with x to the power of negative 3 over 2. Third, we need to find the value of dx by subtracting the value of x and x0. X is the value given, which is 80.99, meanwhile x0 is the value that is the closest to the value given, and when it's substituted, it will give us the value that is integer form chosen by us, which is 81.00. Next, we substitute the value for each of what we find, which are x0, dx, function of f(x), and prime function f(x), into the formula for linear approximation. During calculation, the most important part of this step is for us to do the addition part only after when we find the product of each side of square brackets. Finally, we will get the final answer, which is 2.78.